Hey there. Today, Naisha and I will be presenting our semester-long project, Muse. The condensed version is that it's a genre-based music discovery platform that's available online. However, we'll dive a little bit more into the specifics of what this means here in a second. Okay, so first, before we talk more about the product itself, we think it's important to provide a little bit of background information as to why its existence may be warranted in the first place, as well as how current streaming services have failed to provide certain functionalities to their users time and time again. So the big question is, what made us decide to develop a music recommendation service, and why should you care? Don't larger platforms like Spotify and Apple Music already provide everything one could possibly ask for? Well, the answer to this question is yes, they do provide a lot of useful services, but as avid users of the platforms ourselves, we know firsthand that they don't always get everything right. In particular, these applications tend to be very individualistic, which is good in the sense that the recommendations they make are often well suited to the user. However, in many cases, they lack an element of personalization that would otherwise allow for users to explore new and interesting music. More specifically, streaming giants like Apple Music and Spotify collect information about the user and incorporate it into their overall profile. The problem with this, though, is that any and all played songs are immediately and irrevocably factored into the application's recommender, meaning that there exist many cases in which undesirable listening behavior ultimately affects the user. Such instances would include accidentally sharing your profile with a friend or family member, getting hacked by a third party, playing that one song you hate as a joke, or even just going through an embarrassing listening phase. Additionally, on top of this inability to purge unwanted songs from your listening history, there also exist a few problems when discovering new music. Because the majority of users tend to sit in their own self contained spheres of music and rarely venture out to find new tunes, it makes sense that Spotify's recommender would play it safe, so to speak, by suggesting songs that the user has already demonstrated liking in the past. This is especially evident when it comes to radio stations generated from a particular song, or even when checking out the daily mixes that are uniquely catered to each user. These features, or lack thereof, are obviously harmful to many users' overall listening experience, and there are a few of the problems we have tackled in our application. So, in the ideation phase for Muse, we essentially wanted it to be a one stop shop for exploring, sharing, and saving new music. In order to achieve this, however, it was necessary to implement a few key features. First, we wanted to integrate with both Spotify and Apple Music in order to allow users from both platforms the ability to use our application. We chose these two services in particular because when it comes to the music streaming industry, they indisputably share dominant control over the market. Second, we wanted to allow the user to create separate genre-related profiles from which their preferences could be established and subsequently built upon. This functionality is core to our application, and going back to the problems discussed on the previous slide, this feature would essentially separate users from their complete and comprehensive listening history, ultimately allowing them to freely explore whatever they wanted. Third, we were set on gamifying the recommendation process by adopting the swipe-based mechanism used in a lot of popular dating apps, like Tinder and Bumble. We decided to steer this direction because we felt that in a lot of cases, users become disinterested in an application when too many options are thrown at them all at once. By presenting only recommendations one by one and having the user then take concrete actions at each step, we imagined the swiping process would be more soothing rather than overwhelming. Fourth, we wanted to allow users to tune their profiles by adjusting sliders that determine the metrics of the recommended music. If you wanted to listen to something, for instance, that was more exciting and danceable, sliders would be available for both of those qualities. And finally, we wanted to provide users with the ability to judge songs directly in their browser, make decisions as necessary, and then create and export playlists related to their profile directly to their associated streaming service. Because we were planning to integrate with the Spotify and Apple Music APIs, this decision made sense in that it's likely we're not going to be the user's primary source of music. Instead, our application would simply be used to find new and interesting songs, which could then be listened to later on more established services. As it happens, however, not all of these features managed to make it into the final product. In particular, we ultimately decided against providing support for Apple Music due to the development related struggles that would inevitably follow. Their API is not as well defined as Spotify's, the data received by the two platforms is different, and at the end of the day, Spotify has over 4 times as many monthly active users as Apple Music, so we figured we wouldn't be losing out on much in the long run. On top of this, we didn't accomplish many of the features we initially labeled as stretch goals. After considering the prospects of being able to tune specific music parameters, we found that it sort of defeated the purpose of profiles altogether. And at the end of the day, it's a lot more work on the user's end, is often overwhelming due to the number of choices or parameters, and would likely result in the construction of only a single profile, which ties back into the problem we discussed previously. Additionally, while it would have been nice to include the ability to reclassify swiping history, we found that the functionality was overall pretty niche and would likely not be useful to many users. On top of that, we knew it'd require extra development efforts, and we weren't entirely sure whether we'd be able to get it integrated into our application by the end of the semester. Finally, while it was never officially mentioned in our project proposal, Nation and I discussed the prospect of developing our own recommendation system in an attempt to beat Spotify's. After a bit of research and some rapid prototyping using Python, we found this to be a very, very difficult task and ultimately decided against it.
Now that we've given the context behind Muse, we get to discuss the application and how it's set up. Before we get into the features of Muse, here is a breakdown of the architecture behind it. The presentation tier, or more commonly known as the front end, involves the user interface. That is everything the user interacts with. These were built primarily with React for the component-based body and Sass for the styling. Next, we get to the application tier. This involves all the processing happening behind the scenes. The tech stack for this involves Node.js to run JavaScript code outside a browser, and Express, which is a server framework for building multi-page applications. And last, we have the data tier. This is where all the data we collect within Muse resides. This data cannot directly interact with the UI, but uses the application layer as a middleman. We use MongoDB, a non-relational database that stores JSON-like objects with predefined schemas or templates of an object. Through our time this semester, we got to build a minimum viable product that solves our main problems with the current music recommendation system. Muse enhances the exploration of a wide range of music genres without limitation. It allows users to categorize these explorations into profiles. It presents recommendations in a digestible format while giving the user the option to rate their recommendation. And to tie it all together, it presents these features in a clean, decluttered, and easy-to-use format. Of course, not everything was rosy from beginning to end. We did encounter some hurdles along the way. Initially, we had some difficulty in structuring the data. Spotify's algorithm accepts these genres, artists, and tracks. However, the latter two require reference ID, which is unavailable to the user. We solved this by providing only genres initially, and then passing in the like songs over time. Next, as Muse is a web application, the in-browser experience only allows you to play parts of songs. The Web Playback SDK requires a dedicated Spotify premium account, and we worked around this requirement by playing the track on the user's account while requiring an open Spotify application. Lastly, when it comes to authentication, the user access tokens expire frequently, which requires frequent fetching, checking, and refreshing of tokens.
Okay, so now that you understand a little bit more about the nature of our product, what features it includes, and how it works in general, I wanted to walk you through a quick demonstration of some basic user flows. If you take a look at the leftmost screenshot, you'll see what the user is greeted with upon initially entering the application. Overall, the page is incredibly simple. It only provides information about our logo, what the name of our application is, and a small tidbit about what our service provides. Because it's the only option on the page, the user will naturally gravitate toward the Login with Spotify button present in the center of the screen, which will then of course redirect them to Spotify's login page. Upon logging in, they'll need to agree to some terms that allow Muse to act on their account's behalf, and then they'll be redirected back to our application. Once this happens, they'll be met with a page similar to this one. As you can clearly see, very minimal information is displayed, and it's pretty obvious upon first glance what the user's task is. Because there's a play button centered in the middle of the album art, clicking on it will play a snippet of the song, which the user can then use to decide whether they like it or not. In order to solidify their judgment, two options, an X and a check mark, exist on the left and right sides of the screen respectively. Clicking on either of these buttons will classify the song locally as either liked or disliked, and will then move on to a new one. As you might have noticed in the previous slide, the text contained in the logout button indicates that I'm actually logged into my personal profile, which is why it displays my name. The reason for this is because I wanted to quickly demonstrate to you just how repetitive Spotify's recommendation algorithm truly is. Because I haven't yet created any new profiles and are instead choosing to swipe on the default one imported from Spotify, the recommender doesn't have any genre to source songs from. While it may not be obvious to you, I have actually seen and listened to each and every one of the songs illustrated in these screenshots before, and the respective genres range from gospel music to alternative R&B to indie pop. So, as you can see, without specific profile or seed information, the recommendation algorithm is not only extremely repetitive, as I have already listened to all these songs before, but all over the place genre-wise as well. For these screenshots, on the other hand, I switched over to our application's new account, named Muse, to demonstrate how the algorithm may perform when it has absolutely no data to go off of. I'm not sure if you, the viewer, keep up with modern trends in music, but both of the immediately recommended songs are very popular at the moment, having sourced almost 1 billion listens combined. This makes sense because, with no concrete information to go off of, Spotify will simply recommend what is most popular at the moment, as it's statistically most likely to be enjoyed by the end user. Anyway, moving on to the screenshot seen at the top of the slide, clicking on the Create Profile button will, as described, generate a prompt asking for additional information from which the new profile will be constructed. In particular, the user will need to specify a specific subset of genres from which the profile's recommendations will be generated. These specifications will need to be separated by commas, and upon clicking OK, the user will be brought to their new profile. As you can probably see, the text hanging above the buttons now reads Hip Hop Pop Profile instead of the previously defined default profile, and if you're familiar with these two genres, you'll also see that the recommended music falls almost perfectly in these two categories. Additionally, in the navigation bar near the top of the web page, a list of user profiles are now present and available to the user, which can be used to navigate between them as desired. Finally, as you swipe more and more on a particular profile, once you feel confident in the songs it's recommending, you then have the option to generate an associated playlist. Similar to before, clicking on Generate Playlist will create a pop-up specifying a list of recommended songs, which can then be exported as a named playlist to Spotify with only a single click. Furthermore, the user is also given the opportunity to decline its creation, which is achieved by simply exiting out of the pop-up. And that's pretty much it, actually. If you then take a look at Spotify, you'll see that the generated playlist has been exported and successfully attached to your account, which can then be played at your convenience at almost any time. While the demo was kept relatively minimal in an attempt to demonstrate basic and fundamental use cases, we did a bit of further testing with our product and found that the quality of the recommended songs actually exceeds what you would normally receive on Spotify. This result was actually somewhat expected, but surprisingly, the difference is pretty substantial due to the newfound lack of repetition, which is discussed more thoroughly in our project report.
Now that we've shown you how Muse works and what it's all about, here's what we're looking forward to in the future. To further build on this app, we want to introduce a sense of community. People are a large part of music, and we want to bring that into Muse. We plan to do this by adding functionalities to share playlists between similar music profiles. We would do this by averaging out metrics of tracks within a profile and then match them accordingly. We also want to add the ability for users to reclassify any songs they've swiped through by maintaining a swipe history that users can easily access in the UI. We want to add more features to further enhance the user experience. This includes adding a search bar for seed songs and also allowing the user to listen to the playlist in browser before they export it. Throughout this entire process, we were constantly learning. Mainly, it became clear that it is relatively easy to build upon existing recommendation systems with the right access to data. Community forums have often complained that Spotify is slow to change and remove certain good functionality. That being said, it is very difficult to beat the recommendation algorithms set into place by these services. They have several industry standard engineers behind the code and have much more data than we can ever get access to. And finally, this was a great technical learning experience. We were able to delve into areas of web development and API interaction we haven't seen before. If you have any questions about Muse and its future, please reach out to us via email. Thank you for listening.